Hey, we're gonna go ahead and get started. Hope you guys were able to download Wireshark. If not, you could have that running in the background while we talk about some stuff today. So today's workshop is based around networks, web, and cloud. For the past 2 weeks, we talked about systems and programming, and we really looked at these programs and computer tools from an individual level. With networks, we're gonna start dealing with how computers are able to communicate with one another, and we're gonna go more in depth into how the internet exists and how we're able to have multiple devices talking on multiple networks. Mhm. Right. Just a couple of announcements. Next week, we're gonna have an in-person guest speaker, Greg, who is also a FAST alumni, is gonna come back to us and talk to us about his experience in working in the industry, and along with some other forensics related topics. So we'll have an announcement for the room number because it's going to be different from our normal meeting rooms. So it might be like a different building across from here, but we'll have an announcement on that next week for the location for that. So stay tuned. Okay, so I'm going to chunk it down really easily. We're going to go talk about networks. And then after that, we're going to talk about World Wide Web or the internet and how websites work. And then we're going to end it off with the cloud. And after that, I will be handing it over to Jake, who will be leading the workshop for today with Wireshark. Okay, so let's get right into it. So when I first learned about networks, there was a concept that really resonated with me, and it takes place in the form of this problem. I'm trying to get this share to go away. Okay, so this problem is called the two generals problem. So essentially, you have two teams, team A and team B. I guess team A1 and team A2, and they're trying to communicate and send messages over to another. Um, and you could think of these groups as like armies or what. And in order to send a message, they need to go over the enemy territory in group B to be able to reach the other team. So the question generally asks, how do you make sure that the message that gets sent over is actually sent over? How do we confirm that? If we're on the left side and we want to send a message over to the right, how do we make sure that our message isn't intercepted or disrupted by the enemy here? And the goal is the goal of the message is like you want to attack the middle group at the same time or whatnot. And so you need to tell the other group like the time of when you're gonna attack. Just a basic example, but from what I know, there is no answer. It's impossible to actually confirm that the message you sent across actually reaches the destination, just because you don't have enough information to confirm that. And this question reminded me a lot of how networks work and how we send a whole bunch of data and packets over the internet, but we're sometimes stuff happens in the networks and we aren't able to successfully send over data. And so we have to do our best to confirm that or really develop protocols and systems that are aware of the fact that sometimes things just won't run. And networking deals with a lot of the, I guess, backup issue or like backup solutions to issues like these. All right. So talk more about computer networks and connectivity. So just as like a baseline, computer networking refers to interconnected computing devices that exchange data and share resources with one another. Network devices use a system of rules called communication protocols that transmit information over physical or wireless technologies. We'll show a little bit later on, specifically what we call the OSI model. But ultimately, when we're talking about networks, um, it involves multiple devices sending over data either through some kind of medium. whether they're physically connected with Ethernet cable or they're wirelessly connected. So you're basically sending data over the air. And in order to do that, we need to create specific rules and set protocols to ensure that the method in which I send data to another computer is understood by that computer as well. Because the amount of data and how we send data is so limited on when it comes to the actual physical nature of it, these protocols really help us define how we are going to input data to be sent to multiple devices. All right. So here's just a quick example of what a network might look like. On the images are a little blurry, so I apologize. But on the left image, we have a whole bunch of devices on the outside, and they're all communicating to a central router. So we'll talk a bit more about the devices in a bit, but ultimately, this, I guess, image depicts what a network might look like. So you have some phones and some laptops connected wirelessly, and you have other devices connected physically through a wire, some sort straight to the router. And the router is able to connect to a switch, which is this sort of like an interface, like for networks, and it's able to communicate with other networks and other routers outside of this, what we call local area. On the right, we have something a bit more similar, but it involves other devices such as printers and servers. You have a bit more intermediary devices like hubs, and we have two routers here. And up at the top, we have something called a firewall, which we'll talk about as well, but you might be familiar with what a firewall is. And firewall basically controls the information that comes in or out. It's like a gate to a network. And from there, we're actually able to connect to the entirety of the internet, one way or another. Okay. So we're going to go over a little bit more of the terminology. We'll start on the right side a bit more. So the two different types of networks that we'll talk about is LAN and WAN. As I said before, LAN stands for local area network, which typically includes just a singular, I guess, a central area of where the computers are connected to each other. And if, let's say, I guess moving on, if that's a LAN, we also have something called a WAN, which is called a wide area network. Basically, just a whole bunch of LANs connected together. So if we had, let's say, the right image, if we had another LAN that was connected to each other, like let's say the switch here, through the internet, was able to connect to this network through the firewall and the routers and all those different devices, that would be considered more of a LAN, or sorry, a WAN. So wide area includes multiple local area networks as well. When we talk later about cloud as well, cloud essentially uses that concept of wide area networks and how you're able to access resources and do a whole bunch of whole bunch of things by connecting to networks that are not local to you. Next we'll talk about is network architectures. So this is more helpful for web, but we have two different architectures here. One is called client to server, and the other one is called peer-to-peer. Peer-to-peer is very simple, where you just have two computers and they communicate normally. There is any specific role that these devices have, but they're connected and they're exchanging information one way to another. Client server is a more specific version of peer-to-peer, where you specifically one device is in charge of serving or giving information, aka the server, and the client is any other device or computer that's requesting data from these servers. So more or less one-way communication going on there compared to peer-to-peer. You see client-server architectures a lot when it comes to web servers, so it's important to understand the general terminology and where that comes from. So we'll talk about network devices now. You guys might be familiar with routers and how they work, and possibly wireless routers as well. One important distinction is that modern day routers often have the functionality for a lot of other networking devices. So a hub, a bridge, and switch. These one some way or another in the modern era are also have integrated functions in the router. So the router can act as a hub and the bridge and the switch, depending on what you set to buy. But to kind of go back to the image. So routers are able to communicate with different devices and different routers as well. So if you're, I guess, sending data over the internet, then the packets that you sent are being traveled to one router to another, essentially until it gets to its destination point and comes back to you. Bridges are, or actually, let's talk about hubs. Hubs are actually a bit outdated, but essentially they work the same way. They're similarly to a switch and a router, but they send data to all connected devices. Hubs aren't really used too much nowadays, but it's important to at least know about them and that they exist. Bridges are also similar in the same vein, where usually routers themselves are able to get the job done, but bridges are responsible for connecting multiple, or they're responsible for connecting two different local area networks together. So yes, pretty much the main network devices. You might have some other things here and there, but ultimately these main devices highlight just the important parts of networks and what you need in order to create your own network. Okay, so to talk about terminology, gonna list a couple things down, and if you guys, this is to help just familiarize yourself with these terms. If you don't necessarily understand them, it's fine. But eventually, the more you study and the more you research these things, these terms are very important when it comes to understanding how networks work. So, just going from top to bottom. A network we talked about is just a collection of computers and devices that are able to communicate to each other through some sort of medium. And nodes are just the name that we use for the devices that are connected to a network. If you're familiar with computer science, you might be familiar with nodes on a tree. If that tree was depicting a network, the nodes on it would just be different computers. So that's also another name you could call it without worrying about the specific device. A protocol is a set of rules or standards that determine how data is transmitted. And topology is the physical and logical arrangement of these nodes. I guess I should have switched that order. So there's different, in terms of topology, there's different, I guess, visualizations of how networks are formatted. Maybe you could send data in a chain, or you're able to send data to all other devices connected on that network. So depending on the infrastructure and I guess the main purpose of the network, you might see different topologies that allow you to organize and establish devices in various ways. Actually, yeah. Okay. Next is service provider networks. So these type of networks give permission to take network capacity and functionality on these for the provider. If you guys heard of internet service provider, like AT&T or Verizon, these companies allow you to connect to the internet. Network service providers are the same, but they encompass not only just the internet, but all different types of networks as well. So we're able to have access to different servers and different computers in the wide area network because of these service providers that allow, I guess, make it really convenient, and we don't have to think about how to connect to the network, and they take care of a lot of stuff for us, assuming that you pay for them at least. Okay, so next, really important is the IP address. So IP addresses are unique identifiers for devices on networks. They're used to identify devices and essentially create a very similar, just like a home address for your device. So These are different from MAC addresses, which is the address that comes with the device that you have. Every single digital device that you come across has a unique MAC address. So this MAC address will never change. When you buy the device, when the device is produced, it's given this MAC address to differentiate from different devices. Now, on the other hand, IP addresses can change depending on a network. If I have a network and I decide to join it, it's going to give me an IP address. And there's different IP addresses that exist. I should have put an example here, but they usually be, I guess this is sort of like a side note. Each local network, we'll call it, has a unique number of like 192.168. So a lot of the networks that you're in will have this number, but this isn't referring to the actual IP address of the network itself, but it's just the local address used for the devices on the network. So I guess like a really stupid example is saying like home. You know, I say home and you say home, but we don't have the same home, right? They're different addresses, but we still call it home. So that's when you see 192.168, that address is specific to the local network that you're in. But if you're trying to access different devices through whatever protocol, and you need to specify the device, you'll most likely use an IP address to differentiate that. Okay. So next is DNS. DNS is a protocol that helps us translate IP addresses and domain addresses, which you can see here. So the domain address could be www.google.com. So URL, whatever you want to call it. DNS allows that to be converted into an IP address. So the IP address of Google is just 8.8.8.8. We don't want to be typing that into our browsers. So DNS exists for us to easily access the servers from whatever place, Google in this situation, without having to worry about what the specific IP address that is. All right, so last but not least, we have firewalls. So firewalls are a security device that monitors and controls incoming and outgoing network traffic. Obviously, when it comes to the ease and access to networks, we want to make sure that they're secure and that no one, especially not unauthorized users, are able to join a network and wreak havoc. So firewalls are a good thing, a good tool for us to place and to monitor all the traffic that's coming in and out, and to make sure that the IP addresses, the packets or data is linked with, is basically allowed to pass through our network. Okay, as I talked about, this is the OSI model. It's a bit intimidating. It's not going to be the last time you're going to see it, so don't worry. But it's really interesting to me, at least, because it really shows you how we can get from the abstract concept of the protocols we use in, I guess, the top layer to all the way down to the physical information that's being transmitted on the physical side. So, let's see. So starting with I guess I'll go from bottom to top to just kind of summarize the general ideas. So we have the first physical layer, which includes, I guess, wireless computers and like the physical things. So if you have an Ethernet cable, which I think is one right here, you may have seen one before, probably most likely, but that is the information basically set that's usually represented in like bits, ones and zeros, is going to be that physical. So ultimately, because we can't send like complex forms of data, like integers or even strings and like very complicated things, we can't really do that on metal. You know, it's really difficult. We just use the states of whether electricity is passing for like physical things, whether electricity is passing through, and whether it is or isn't depicts whether a 1 or 0 is sent. And from there, we collect all the 1s and 0s and put them in order, and we slowly translate them through more complex and abstract forms of data until we're able to get something that's a bit more understandable. So next, after the physical layer, we have the data link layer, which uses frames as the main abstract idea that encompasses the data. And from there, we have the network layer, which uses packets. And in the network layer is where we also use the IP addresses and what we talked about before, and other protocols too, such as ICMP and IGMP. After the network layer, we have the transport layer, which uses TCP and UDP. For if you're dealing with the transport layer, you're going to see TCP and UDP a lot as well. The main difference is that for TCP, the end-to-end communication goes both ways. But for UDP, it's actually just one directional. So it's when you're sending UDP, I guess, packets, you don't expect anything in return. You're just kind of spilling things out. After that, we have the session and presentation, which in some models, like the 5-layer model, that doesn't exist and is usually integrated within the application layer, but I personally like seeing all 7. From here, we have the session layer, which deals with sockets. The presentation layer deals with other syntactic layers. So protocols like SSH and SSL and IMAP, FTP, that's all done in the presentation layer, which is more similar with the application layer, which also does that as well. So some difference there, but not too many. And from all the way down to the physical side, we slowly add something, we slowly add another layer, and we kind of, we basically encapsulate it into another, I guess, packet or frame, and we're able to have a complex messaging system through whatever application protocol we decide to use. Okay, so now we're going to talk about the web. So as I said before, the web is based or really highly based around the client-server model, where the client receives a response from the server, which could either include requests, web content, services, or resources. So in this image here, if we have our clients or just, I guess, our laptop and the server google.com, and we want to get web content from Google, we're going to send it through the internet. It's going to hit the servers. The servers are going to serve us the web content. It's going to come back to us on our browser. So we'll go over the terminology as well, which also helps clear things up. So World Wide Web is based off of multiple technologies such as web browsers, HTML and HTTP, which are the 2 main tools used for web. HTML is the language, you could say, in which web content is returned, and your browsers are able to interpret HTML and to display some sort of physical interface to you. HTTP itself is the actual network protocol that allows HTML and other data to be served to you or to the clients that ask for it. Web browsers themselves are just programs on your computer that are able to process HTML. This web browsers are basically application software that allows you to explore the World Wide Web and request data from multiple servers, and also using DNS, because it's able to use DNS. If you also search up just IP addresses on your URL for the browser, it'll do the same thing, but built-in DNS allows us to also use domain names instead of just IP addresses. Web servers are just a program that's able to process, okay. Web servers are just programs which process network requests and then is able to serve them with whatever they ask for, whether it's HTML or just data. Web pages themselves is just a digital document linked to the web and is visible to anyone who has the internet and is not blocked on like a firewall, I guess. Last but not least, web development is the process of creating, writing, and publishing, programming, web-based technologies and databases as well. And it's encompasses the creation of application that works over internet and websites. Okay, so let me see if, all right. One thing I do want to talk about, especially from the cybersecurity standpoint, is that I'm not sure if I forgot to talk about this up here, but in terms of web content itself, the the infrastructure for whatever web server that you might have on the application sense, so when you're writing a website, is usually divided into the front end and the back end. The front end is the UI or the visual side of what you actually see on the browser, and the back end tends to represent all the inner workings of the website and the things that you don't see as the client. And the front end is linked directly to the web pages, while the functionality for how data is moved between the user through the front end is handled by the back end. Pretty self-explanatory, front, back. One important thing that websites use are databases. In order to store information, websites are connected to various databases to hold information that needs to be recalled, whether it's account information or other user profile information. They could also be connected to external services outside of just databases as well. So if a company has a web service that allows you to, I guess, use, actually, we'll use an example. So ChatGPT, as you might know, has something called APIs, and a lot of companies have something called APIs as well. It's an abbreviation for application programming interfaces. As a web developer, I can use APIs to integrate them within my website. And so I have to get a key, but after I configure everything and do some programming, I'm able to use that external service to basically use a chatbot in my web application. So yeah, so back to regarding databases. Databases are really important because if not secured properly, maybe an unauthorized user is able to access information from that database through just the UI that they have. Maybe they could maybe they could do some hacking through the actual web interface, or maybe they could send data to the server that's serving the information. But overall, because websites allow the transmission of sensitive information, it's really important that we are able to secure websites and to make sure that they're working properly without leaking any data. So web application penetration testing, or just web app penetration, is a huge topic and also a very big subsection in cybersecurity. And so if you're interested in more on like the hacking side of things, web app penetration is like very much fundamental and important for you to know. And it also helps develop other skills that lead up into pen testing as well. But to talk more about the cybersecurity side with web, you usually have 5 main steps when you're penetrating a web application and seeing if there are any vulnerabilities. These steps include reconnaissance, which is finding any open sources for information regarding that website, and if there's any information that's just leaking out to the public. Scanning is the active search of information, where you're looking at all the ports from the server that's serving the web content and seeing what other applications are running. Enumeration is, I guess, sort of the logging process of that. Exploitation is the actual, I guess, exploiting of any vulnerabilities that might exist. And reporting is sort of the final step, where you create a report on all the things that you found. Because as a red teamer, your main job is to find vulnerabilities and to tell other people about them so that they can be fixed. Okay. Some common vulnerabilities you might see for web penetration is cross-site scripting. Cross-site scripting allows the actor to target other users on the application without their I guess, authority. There's also cross-site request forgery, which is an attack that forces a user to perform unintended actions, like changing their password to transfer funds to the attacker's account. There's also information leakage, which allows the attacker to get information about an application and the data that it uses. This could also include unremoved comments in the source code for websites or poor error handling from a user. Lastly, we have broken access controls, broken authentication, and SQL injection. SQL injections are actually similar type of information leakage. SQL is syntax for getting information from a database. So there's a common vulnerability called an SQL injection where certain user inputs they aren't necessarily sanitized to make sure that a user can't use SQL syntax to get information from it. I don't have an example here, but if we had a user input like a username or a password box where a user has to type in their username or password, and if you put in some SQL code, that text for the username will get interpreted as part of the SQL that's sent to the database. And so you could maliciously tell it to give you all the information or do other things if the user input that's given isn't sanitized correctly and is not checked for that. So through SQL injections, you are able to get a lot of information leaked out. Broken authentication is any sort of vulnerabilities that deal with deal with accounts and authentication. This can include weak passwords or I guess brute forcing login attempts and trying to see if there's any accounts that might be vulnerable that haven't put up a weak password. You could use like password crackers to try and do that and try and get access to another person's account. Lastly, we have the broken access controls in the middle there, which is just when a web app fails to protect its data and the user admins, which enables an attacker to access data it shouldn't be allowed to. Pretty much similar and on the same basis of the other things we talk about. But if we have like an admin role on a website that's only meant for, I guess, developers or certain people, if a non-admin user is able to get the permissions that an admin might have, that would also be pretty bad. Okay, so that's all for the web. Now, lastly, we're going to talk about the cloud, which is also really important. So as we mentioned before, the cloud is essentially a part of the wide area network, and we're able to connect to the cloud almost like anywhere, if that makes sense. If you go to the second bullet point, so cloud works in the same way as cloud services you might have used, such as Gmail or Microsoft or Office 365. It also works in the same way as Google Drive or Dropbox. Ultimately, when we use Google Drive or Dropbox, all the files that we stored there, because we use just a web interface, they aren't actually stored on the computer that we're using. All that information and all that hardware is stored somewhere else, aka the cloud. And so it's called the cloud because it's in the sky. You don't really know where it is, but it exists. It's very mysterious in a way, but ultimately, these are just hosted servers, hosted computers that are that exist in a different location from your actual device. So you see here, a lot of websites and a lot of services are actually hosted on the cloud. So in this image, we just have like a user device that connects through the cloud via the internet. And on one of these servers contains the applications and database that a website might have. This is a lot cheaper than buying physical infrastructure. We live in a day and age where cloud technology is very ubiquitous, and you don't want to be buying your own server and your own hardware to host a website that you want, unless you're into that, that's cool. But generally, you do not want to be spending that money to get all the physical requirements and be in charge of managing all the systems and all the overhead for having your own server. It's just very costly, and the cloud offers a very manageable way to be able to host websites and other applications on the web. Okay. All right, so two concepts that come with the cloud is cloud computing and cloud services. So when it comes to cloud computing, this is the delivery of the services that you have hosted on the cloud, and how you'll be able to serve that to the different clients that you have. You typically only pay for the cloud services you use. And so this is really efficient in terms of the infrastructure that you have and being able to run it, as well as the operating costs that come with it. Virtual machines that we've talked about before can also be used on these servers and make it really efficient for the hardware hosting them. So the great thing about the cloud is that it's very flexible, and depending on your needs, it will be able to transform and meet your needs that you have, whether it's the amount of, I guess, the throughput of users, how many users could connect, and being able to be dynamic in how that works. And depending how big you are, it'll adjust the cost that you pay or the price that you pay for them. And virtual machines help a lot with how that works. And also, because they use virtual machines, we could use whatever operating system we want on the hardware, which makes it even more convenient. Okay, lastly, for cloud services, these are just services that are deployed through the cloud, but usually they're also in tangent with the company that provides it. There are different services that can be offered, especially in the picture on the right here. So these, I think there's a lot more, but this image is a general good baseline for understanding cloud services. So these letters here, we have IaaS, PaaS, SaaS. This stands for infrastructure as a service, platform as a service, and software as a service. So in the same way that we might, if you were a cloud provider, the same way that you could, I guess, offer hardware for different, I guess, customers that you might have, you could also take that to another level and offer different, I guess, software related things within just the hardware. And usually they build on top of each other. So if you're providing software as a service, then you imply that you're also having the servers and the physical devices needed for that. So kind of going from the bottom to top, the infrastructure as a service is talking about the actual servers, the networking, and the storage where your servers are located, and also the physical data center that has the servers. Platform as a service includes the operating systems that are on these machines, and database management and development tools. And at the end, software as a service are just entirely cloud-hosted applications. And you guys could, there's a whole bunch of other ones. There's also like function as a service. Like that. If you're really interested on the different services that cloud providers offer, then you guys could easily be able to search that up. And I would think we'll go do that on the next slide as well. Just to make sure I didn't miss out on anything. Yeah, so the cloud services are able to conduct data analysis, processing, sharing, and storage without needing an IT department to oversee. So these are very versatile and very cost efficient. Cloud services manage a lot of the tedious things required for hosting applications and are ultimately the future of technology in a way. These are going to be prevalent even more in the future, if not already. So it's important to know how the cloud works, what it is, and how we'll be able to see it grow over time. Okay, just to go over these links, I use these links as just general informations for my slides as well. But you could see here that they have I guess this is sort of the product they're giving out, and so they list a whole lot of benefits that they have. Security is also a big one because you don't have to worry about the actual infrastructure being hacked. Yeah, you also have serverless computing and other things here. And there's a lot of use cases for how these are used. I think this one is pretty similar, but it talks a bit more about like the general overview idea and how different cloud computing services offer different forms, different architectures, different, I guess, benefits depending on what you want. So really, really versatile. And so there's in the world of technology, there's oftentimes another individual branch of, I guess, integration with the cloud. So cybersecurity and how it works with the cloud, software development, and how it integrates with the cloud. Okay, so I think that's about it. I hope that wasn't too boring for you guys, and that I hope that at least something in there was pretty interesting or new and insightful. Before we go on to our main activity, the previous slide had some links for I guess the resources that I cited, but if you're more interested about learning more about cloud, you guys could check out the links in the previous slide there, or just use YouTube, especially for networking. I found that visualizing and having maybe some videos show like some animations was really helpful for me. So if you search up a whole any concept on networking, you'll be able to find a lot of good resources out there that'll help you understand how networks work, because they are very complex, they are very abstract, but I think they're very so that's about it. So I'm gonna give it over to Jake, who will help us guide us through this activity. So yeah, thank you guys so much. Yeah. Oh, you're gonna use your laptop? Probably. Probably. Okay. Just HDMI. Do you have one? Oh, is it? You have a Mac. Yeah. I think you could USB. Oh, it might we actually might have one. Yeah, I think we have a USB. This is USB, right? No? No, okay. USB-C. That's fine. I think you should have share permissions. Okay. So you could just bring up your laptop and do that. No? Are you sharing? No. Okay. Give us one moment while we set up our things here. You're gonna use Discord, right? For the packets or the
Yeah, I put the
Okay.
packet capture on Discord.
for sure. Just make sure you tell people about
Yeah.
Just make sure you go through the process.
Yeah. Don't worry. Put it all down to the sides. All right. Let's do some Wireshark. Hopefully everybody was able to install Wireshark successfully. If not, that's okay. You can follow along. It's perfectly fine. We will be using a packet capture that was provided previously. You can find this under the workshops tab in the general fast Discord. It's just the intro-wireshark-trace1.pcap file. go ahead and download that, and double clicking it or opening it with Wireshark will allow you to see the interface.
What's a PCAP file?
Packet capture file. So when you have things on the internet communicating, they transmit their information in what is called packets, and then we can basically watch those packets as they are transferred across a network and then capture them, save them into a file, and then we can go back and look at them later. So you'll see that with a lot of like Wireshark's primary usage is like a packet sniffer. So it just sits on your network and eats up all the packets that are transferred over the network. And then you can go back and look at it to see, what's been going on, who's been visiting what websites, files that have been downloaded, stuff like that. One thing I should say though, do not do that. That is illegal if you don't have, you know, the go ahead from whoever owns the network. If it's your home network, it's fine. But since we're on the school network here, you should not be sniffing with Wireshark. That is highly illegal. If the school finds out, they can punish you, and it'll probably be a pretty severe punishment. All right, so let's see. Everybody has the intro Wireshark file downloaded, Wireshark's working up. You should see just something like this right now, a whole bunch of junk, a whole lot of packets as well. All right, so let's go ahead and actually. Okay, perfect. Okay. So let's go ahead and take a quick look through this file. Like I said, there's a lot of packets here. There's a lot of stuff going on. Most of this is just noise. But what we are going to be focusing on today is a simple just HTTP connection to a website where we downloaded a file and the website responded. So there's just a whole lot of TCP junk. And we're going to look for our HTTP. As you can see right here in the green, we have our TCP connection and then our HTTP connection. So every packet has a primary protocol listed. These HTTP packets, if you click on them, you can see that they use TCP, Transmission Control Protocol here, as well as Hypertext Transfer Protocol, HTTP. But HTTP is listed as the primary because that's what it's using to communicate with the network. You can see on the left side as well, there's this little kind of bracket going on. If we go ahead and go to our get, where we ask the server for information or for a file, and right click, we can hover over to follow and click on follow as HTTP stream. This will give us the get and then the request. So the red is our get. We want this file up here. And then the blue is our request. The server has deemed this okay. They have the resource, they pass it on to us, and they've responded with this as well as our file. But if we go ahead and close that, you'll see we've applied a filter to our search, and now it's only listing the stream of HTTP, or not just HTTP, but packets that are involved in this HTTP communication. So you can see the filter at the top has been changed to TCP.stream equals 5. I believe that's kind of just an arbitrary number. It depends on what packet capture you're using and how many TCP streams there are. But you can see we start off with our TCP handshake. If you don't know what that is, TCP, as Brad was mentioning earlier, it's a bidirectional communication. So when you communicate with the server, you always expect a response to make sure that everything that you transmitted was transmitted successfully. UDP, you don't expect a response, so you're kind of just vomiting packets out. But TCP has to start with a, hey, are you listening? Yes, I'm listening. So we will be functioning as 10.0.0.44, and the server will be 128.119.245.12. So we ask the server, we want to synchronize with. The server gets that synchronization request and acknowledges. Then we send back the acknowledgement that they have synchronized with us, and we are ready to begin transmitting data. Then we give them the GET request, and they acknowledge that they got the GET request, so they send us back an acknowledgement. Then they send us the 200 code OK with our data that we requested, and then we send them back an acknowledgement that we received the data they gave us. And again, going back to the filters, you can search by protocols as well. So if we want to just look at what is HTTP, we can see 2 GET requests here and then 2 return requests here. One of them we do get what we want, another one we do not. You can see the codes here. HTTP 200 means okay, 400 means not found, or 404 means not found. There's a few other codes out there that you'll see when you visit websites. 404 is probably the most common, where the website page will not load because the resources that you're asking for just don't exist anymore in the server or in the cache that you're using. All right, so a bit of preliminaries out of the way. I guess I should explain as well. So this kind of frame up here, or pane, I should say, this shows all of your packets that you've filtered. If I just go ahead and delete HTTP and hit enter, with no filter, it shows us every single packet. But we want to focus on the HTTP protocol, so we'll just go ahead and type that in. A green highlight over your filter means that it's an acceptable filter. There's red, which is an unacceptable filter. It won't filter anything out. And yellow, which is a questionable filter. It's very unreliable. You might not get everything that you're looking for. Down here in the second screen, some might have a bit different. This second screen might be on the left, and this third screen might be on the right, or they might be stacked on top of each other. It's basically the same thing. So this just shows you the kind of decoded packet information. So everything from the OSI model that Brad was talking about. So we have the physical, we have our Ethernet, IP, transmission, and then the hypertext application at the top. And then down here is just the raw data of the packet. You can see we have all the hex data here on the left, and then the translated data on the right here. But it's still kind of hard to understand. That's why they put it into nice little drop-down menus for us here. We can see all the same stuff transmitted neatly. So let's get to asking some questions. How many packets are in the PCAP file? There's a super easy way to do this. Most of the time, you'll see people go over to like statistics and then click on capture file properties, scroll down a bit, and you'll see our measurements over here. You can look at everything you need to see: packets, time, average packets per second, average packet size, average bytes per second, bits per second, yada, yada, yada. But what we're focusing on is our capture packets, 651. So there's 651 packets in this packet capture, and we are only displaying 4 of them with our filter. That will change depending on what filter you have. For us, we just want to see HTTP, which shows us 4 packets, so we're displaying 4. You can also see this all the way down here at the bottom. It says packets 651 displayed 4.6%. Same thing as what we saw in statistics. So 651. And how many are using HTTP? Like I said, just 4. All right, so let's take a bit of a look at the actual packet itself. So when we talk with a website, we want to download this file, this intro to Wireshark file.html, so we can display the website on our own computer. So the server's got to give us that. So we ask for a GET, and we do this whole thing with the GET request, give it a bunch of data, yada, yada, yada. But we want to look at the transmission control protocol. So each packet, when it's transmitted, or excuse me, it's actually over in the Internet Protocol. So each packet, when it's transmitted with a bunch of data thanks to the IP protocol, or the Internet Protocol, IPv4. That's what everybody uses right now for the most part. There is IPv6, but it's a bit of a slow march to get that implemented. But you can see a bunch of different information here. The length of the packet, an identification method, and our time to live, as well as a protocol that's being used. TCP is listed here, as well as HTTP. You can see on the actual Wireshark frame. Bunch of other stuff here, as well as our source and our destination IP addresses. So we want to ask, or we want to get, what is the time to live of the first GET request? So looking at our first GET request here, going into the Internet Protocol version 4, and scrolling down to our time to live is 64. Now, time to live is just essentially how long the packet can persist on the network. I believe this is around, I think this is measured in seconds. I'm not quite sure, but either way, it's really quick. If the packet isn't picked up or transmitted in time, then it is trashed and has to get resent. Some protocols will automatically resend packets that are lost. Some protocols will not. That kind of depends on what you're using, and it can end up in loss of packets and data, which is not good. But yes, so we want to look at the time to live, our TTL, and we can see that for this packet, it's 64. If we go to our return request of 200, we can see that this packet has a time to live of 53. Our next GET request also has 64, and our last return has a 53 as well. But we just want to focus on the first GET request, which is 64. So what is the IP address, the server it was sent to, as well as what was the port number? So again, in the Internet Protocol version 4, we get all this information, and we can see the destination, 128.119, 245.12. But we can also see this in the summarization frame up at the top, where you can see our source and our destination. Again, 128.119, 245.12. But we also want to know the port. So it's using the transmission control protocol to transmit this packet. So if we look at our TCP, just go ahead and minimize this. If we look at our TCP, we can see our source port, which is where we are sending it from, is 53.962. And our destination port is just 80. So the IP address is this whole string of numbers, 128. And then our port number that we found out would be 80. Did the request succeed? Again, you can kind of just look at the packet summarization at the top here, or go into the packet and actually research for yourself, but it just shows it at the top. Our HTTP request was responded by the server with 200, which is translated to OK. So yes, it did succeed. We got what we wanted, and it returned what we needed. All right, so in addition to getting a bunch of information about the actual packets, we can also get a lot of information about the user. So if we go back into this GET request and take a look, not in TCP, in HTTP, this HTTP protocol gives us a lot of information about the actual user. So we can see here our host, which is our destination, at gaia.cs.umass.edu. Those guys are over at 128, but we have all this information that we get from sending this one packet. So we are using Mozilla, which is Firefox, on a Mac, using the operating system Mac OS X 10.15, which I believe is some old 2019 thing. And then Gecko, and then Firefox at the end here is the browser we're using. So it gives us all this information just because we sent one packet over the internet, which is a lot of information you can get just for free. So we deduce that we're using Firefox. And we also talk about we're using Mac OS X 10.15. And then we can also take a look at more information down here. We can see some cookies right here. Again, this is HTTP, so not HTTPS. There's a lot of insecure stuff. But there's also, we can look at the full request URI, which is the full URL of the resource that we want to get from our server or our host, gaia.cs.umass. So the full URL would be this entire thing, HTTP, Gaia, CS, UMass, edu, Wireshark-labs, intro-wireshark.file.1.html. So all that is the full URL. that brings us to the resource to get what we want. All right. So similarly to what we did with our sending, with our GET requests and how the host sent it, we can get a bunch of info about the host. We can also get a bunch of info about the server. So again, in their response to our request, we can see a bunch of server information. So we can see that the server is Apache 2.4.6, running CentOS, using OpenSSL, PHP, ModPerl, and Perl. We also get some information about the file itself that we requested. So this was requested on Wednesday, January 27th, 2021, and it was last modified on that same date, just a few hours earlier, actually. This was sent at 1900. This was modified at 6, almost 7 in the morning. Again, a bunch of other information that's kind of useless to us right now. Yeah, and then, of course, the full request URL of where that file is actually located on the server. But we want to ask what kind of server returned the GET requests. So if you remember, we go back here and check the server information. We can see that it was running Apache. So that is what we want. And what message is returned by the server along with the requested file. So when the server returns an HTTP, you can usually see, if we minimize this, our line-based text data. So this is what's returned by most servers when you want to view a web page. It'll just spit out all the raw HTML for you to look at in this packet. So you can see we have our HTML formatting, our new line indicators, and then congratulations, you've downloaded the first Wireshark lab file and a new line, and our HTML closer. There we go. So there's a lot more you can do with Wireshark, but I wanted to keep it to just a few preliminary stuff. Easy to understand, easy to digest. There's a lot of the power that comes with Wireshark is learning how to filter. So filtering out protocols, different protocols. So if you want to look at, oops, not that, just all the packets using TCP. Obviously, that's a majority of this packet capture. You can see 631 out of 651 packets are displayed. So that's showing us basically the entire packet capture. So knowing where you want to find your information and what protocol they're using, what information you can find in there. We can also search inside the packet. So if we type, I believe, something like this. Okay, there's a way to search the actual frame of a packet, which is this like little jumbled bit of translated information at the bottom. But I forget the keyword that you're supposed to use after frame. I thought it was includes, but I guess not. But you can say like you can ask the filter for all the packets where the frame includes some string of words, and it'll return to you all the packets that include that string of words. For example, here, if I wanted to look for something that in our response said, congratulations, you've downloaded the first Wireshark lab file. So if I just search for the word like congratulations, then it would return back something, or would return back that packet and let us know that there are packets with that stuff in that frame. I can sit here and could be contains. Ah, very smart, very smart. Yes. So there you go. Solved. Frame contains, and then in quotes, whatever string you want to look for. And it will show you the packet, so you can see there's only one packet here because this is the only packet that actually returns something good. You have congratulations, Dan. But yeah, that is the basics of Wireshark right now. This is a pretty simple packet capture. I think maybe in the future we'll probably look at some more complicated stuff, but it's only 5:12 right now. What are you thinking on time?
Oh, I mean, pretty much fine. You said you had a second one, right?
There is, but I haven't taken a full, like, extensive look at it, and I was honestly just planning on running through it with the people in the room and seeing like if we could solve questions. It's beginner level,
I
like it's
see.
probably not
Is
gonna
it
take us
online?
long. Yeah, it is.
Okay.
I can post a link to it if you want to do this as a
What we
take
can
home
do,
thing.
since we have a lot of time, we could spend some time individually for people to look at it, then
Okay.
go back and then do some answers. So you guys could get some time to try some stuff on your own. Um, I hope it's not too intimidating. Well, I remember when I first tried Wireshark, there's like so much information that
Yeah.
I couldn't get my mind. But over time, you get used to it, and the more you do it, the better you get, the more
Yeah.
familiar you become. So I really encourage you to just take that step and to explore the unknown, and hopefully, we will go somewhere from there. So.
Yeah, like I said, Wireshark is all about knowing how to filter, what to look for, where your information is. It looks like a big wall of text, but once you get used to it, you can pick out each individual data point that you need to look for. There's a lot of free resources out there to strengthen your skills in Wireshark. I know TryHackMe has a few free courses that'll let you or give you more information on how to navigate Wireshark. A few of them. Yes, taking the computer networks class definitely helps explain a lot of the info in Wireshark. That is very true. I'm in that class right now, and that professor pretty much only assigns homework using Wireshark. So it's very nice to kind of get that deeper dive into how computer networks work with that tool that I've been so accustomed to at this point. So it's a very nice breakdown. But for the time being, we have a kind of tertiary activity. So this website, Let's Defend, it's all about blue teaming. There's a bunch of stuff on here. You can sign up for free. You should not pay. I don't really know what you get for paying, but you don't need to pay to do this one. It's free. It's called PCAP analysis. And basically what it is it gives you a lab environment or an online, basically, Linux machine that you connect to. It's got Wireshark installed and it's got the PCAP file that you need to answer the questions installed as well. So it takes a few minutes to start up, and you do have to make an account, unfortunately, to use this website. I just use the email. But yeah, so this can be, if you guys want to try this out as well, make an account on Let's Defend, look up PCAP analysis under the Learn tab, and it should come up with a challenge. So you'll see there's the machine here you can connect to, and then there's, I believe, 6 questions. Yeah, 6 questions, all relating to that packet capture. So for the time being, if you guys have any questions, please let me know, but we will be working individually. I'll be trying to work some of this stuff out as well as we go. So hopefully I can answer some questions when the time comes. All right, we're getting close to wrapping up here. How's everyone doing? Yeah, I get it. I've been there. Don't worry. Take some time, but I believe in you. I'm sure you'll get through it. This Let's Defend website. It's the first time I've used it before, but so far it seems pretty all right. Uh, Somewhat similar to TryHackMe. Um, TryHackMe has a bunch of boxes that you can go into and kind of just mess around on, answer questions and stuff like that. But yeah, so I think for the time being, I will kind of leave this up to you all to answer the questions. So I'm going to withhold answers for now, but if you would like answers or a walkthrough or whatnot, just message me on Discord and I'll let you know how it goes. and solve the problems with you, give you a step by step. But for now, I think we're all good. Anything else you want to say? Yeah. Sure.
Thank you, Jake, so much for helping out with this workshop.
No worries.
Talking about the Wireshark stuff. Next week we will have our guest speaker in person, as mentioned beforehand. And possibly more updates on the workshop on Friday as well, if we decide to have one. We're still figuring out what to do that day. So more information will be coming out, but other than that, that's pretty much all for me. So thank you guys so much for being here, and I hope I'll see you guys soon. Thank you guys.
Yes, you, Brian. Thank you guys for presenting.
Thank you.